Okay, picking this up. We left off here. I cleaned things up a bit, by the way, since you guys left. Tried to make it clearer what was going on. So ZE5 would be the equivalent of this network here. We had not yet finished figuring out what the impedance of this network is. We have the admittance, but not the impedance. So ZE5 is just going to be the reciprocal of 0.3 minus 1/10 J, which is 0.3. I'm multiplying by the complex conjugate on the top and the bottom. So 0.3 squared is 0.09, and 0.1 squared is 0.01. These two add together to a tenth. 3/10 divided by 1/10 is 3. 1/10 divided by 1/10 is 1. Okay. Now that we've got all this blue stuff here, and we can just add it to the green, to this ZE1 right up here. So ZEQ is going to equal 0.8 plus 3, 3.8, plus 1 minus 4/10. There. Final answer. 3.8 plus 6/10 J. Let's see what the book says. And I'll erase all my markings on the slide. Erase the ink. And write down my answer. Okay, let's see what the book says. So they go through this, they figure out the equivalent impedance, Z4. They call this Z4. I'll just mark that, Z4. And then they get Z3. They add Z4 and Z3, I'm pretty sure. Eventually they're going to. So this is Z2 here. Pick a red pen. There we go. Z2. Z3. Z4. And they call this Z1. I think I even called it Z1. I'll just circle Z1. Okay. Now, and they figure out, yeah, they figure out all this stuff. They get it all normalized into complex numbers. And then they have this network here. So the sum of these two, Z3 and Z4, 4 plus 2J minus 4J, Z4 minus 2J, Z34. 2, 3, 4. All three of these, it's the parallel resistor combination. And they don't show the numbers, but they crunched them. I went and put my answer right on top of theirs. And I wonder if I can move it. I don't think I have any move tools. I'd have to do it some other time. Okay. Admittance 2. Let's see, where are they going with this? This admittance number 2 here. There. This admittance. Are they there? Right there. This admittance. 2 plus 4J. Yes, they are. So Y2, so we've got a parallel combination between so we get this and gee, it looks like they stepped backwards a bit. There's Y2, there's Z2 right here, right there. So they need to add the admittance of 2 to the admittance of 3, 4. Where's 3, 4? Yeah, there it is, 3, 4. Which is exactly what I did, by the way. There it is, Y3, 4. They're adding the 2 admittances together. Okay. And they got all their admittances going, and the impedance, and that's how they derived this right here. They skipped ahead. They skipped some math steps when they wrote this down. And finally, ZEQ, just adding the Z1 up here, adding it to the equivalent of everything else. Adding it to the equivalent of everything else, which is 2, 3, 4. 3.8 plus 6/10. And there we go. Up here, it's hidden by the by this, but 3.8 plus 6/10, just like before. Let's go to new octave to see if this makes sense right here. I got to find new octave. There it is. And did I already do that? Yeah, I should have. So I had negative 8.97 degrees and absolute magnitude 0.25. Or that's the Y, 0.256. There we go. And they got the Z. Let's go back to new octave and do the Z. Do I have? I didn't do it for Z. ABS of Z equivalent and ARG of ZEQ times 180 over pi. Converting from radians to degrees. Okay. So I got 3.8471 plus with an angle of 8.9726. Is that what they got? Yep, there it is. 8.47471, just the same as they got. Okay, this shows you how to go about doing this stuff, breaking it down into pieces. Now it's your turn. So the rest of this stuff is pretty much, the rest of this stuff is just going through more and more complicated problems. This one is just working with the complex numbers, series resistance formulas, no problem. Okay, now I'm going to go on to phasor diagrams. We've already seen the phasor notation. Going to do phasor diagrams in the next video.